Welcome back to Organic Chemistry. Today we will be starting with a new chapter called Nitrogen Containing Organic Compounds. This is a very interesting one and it's a very important too as far as IIT-JEE is concerned. These compounds are generally called as amines. Now let's look into the properties of these amines and the methods of preparation. Amines are of three types: primary amine, secondary amine, tertiary amine. As the name suggests, these amines are derivatives of ammonia, which is NH3. A primary amine is like RNH2, where nitrogen has two hydrogens, and a secondary amine is like R2NH or Rn some R dash H, whereas a tertiary amine has no hydrogen. That is, N doesn't have any hydrogen, and R dash, this can be R double dash. Now let's go to the nomenclature of it. In nomenclature we have first secondary prefix, next comes primary prefix, next comes root word, next primary suffix, and next comes secondary suffix. Now if you look, the secondary suffix is functional group. For amines, the functional group is called as amine. Let's look into the examples of these. For primary, let us consider an amine like CH3NH2, and for secondary, let us consider as CH3NH C2H5. Whereas for tertiary, let us take CH3 and CH3 C2H5. Now the name for this one is, here the alkyl group is methyl, so we write it as methylamine, because for amines, for primary amine we write as alkyl amine as for IUPAC nomenclature, and for secondary we write N-alkyl alkyl amine, whereas for tertiary we write N-alkyl N-alkyl alkyl amine. So this one is N-methyl N-ethyl, or here it is not N-methyl ethylamine. Whereas for this one we have N-dimethyl ethylamine. Now as you can see, this alkyl and this alkyl are chosen as for the alphabetical order. Now if you take between methyl and ethyl, letter E comes first to letter M, which is the methyl group. So alkyl is the ethyl is written here, and the methyl is given second priority, so it is written here. Now let us look into the isomerism of these amines. In the isomerism, first let us talk about structural isomerism. Amines exhibit structural isomerism like chain isomerism, positional, functional group, and metamerism. Now let us see how these are exhibited. First, let us consider an amine which is for chain isomerism, let's consider CH3, CH2, CH2, NH2. As you can see here, this is propylamine. Now this, for the same molecular formula, we can also have a structure like CH3, CH, CH3, NH2. As you can see, the difference between these two compounds is the chain between them. So these are chain isomers. If you want position isomers, it comes by shifting the functional group which is amine, that is CH3, CH, CH3, NH2. As you can see, here the amine group is on first carbon, whereas here the amine group is on second carbon. So let us see how the amines exhibit functional group isomers. You know that primary, secondary and tertiary amines are functional groups which are different. So if you have a compound, say N, C, 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 it can have a structure like N, 3 carbons here and 2 here. As you can see, here the functional group is changing because here the nitrogen has 2 hydrogens, whereas here it has only 1 hydrogen. So this is primary and this is secondary. As the functional group changes, you get functional group isomerism. Similarly, you can take any structure and write a tertiary one also. Now let us see the metamerism. To exhibit metamerism, we know that the group should be polyvalent. That is, you should have a polyvalent functional group. You know that nitrogen is a polyvalent because the valency is 3. So for the same functional group which is polyvalent, now if you have exchanged alkyl groups, you are going to get a metamerism. Let us consider an example of secondary amine, say this one, where you have 4 carbons on one side and on one side you have only 3 carbons. Now if one carbon is shifted in this in here, you are going to get 3 carbons on one side and 3 carbons on other side. As you can see, this one is obtained by shifting the alkyl groups from one side of the polyvalent functional group, which is nitrogen, to the other side. So these are metamers. Now let us move to the next part of it. After dealing with the structural isomerism, let us come to the next part of isomerism, which is stereoisomerism. Here we will be dealing with mostly on optical isomerism. First, consider a primary amine like this one, NH2R, nitrogen has lone pair. As you can see, this is a chiral molecule or a chiral center because 2 of the hydrogen bonded to it are same. So this doesn't show any optical activity. Now let us consider a tertiary amine like this one, or say R, N, R dash, R double dash. So consider this tertiary amine. If you take the mirror image of it, you will get N, R dash, R double dash, R, and one more lone pair here. As you can see, these two are non-superimposable, but if you take this compound or this compound, it won't show optical activity. This is because rapid interconversion between these two isomers exists. That is, if you take a mixture of, say, this compound, let's call it as 1, and let's call this one as 2. In this mixture, 1 gets converted to 2 and 2 gets converted to 1, and you are going to get an equilibrium between them. So the resulting mixture would be a meso one. As a result, do we call it as meso? No, this is not meso. This is racemic mixture. Because both the enantiomers are present in equal amounts. So this would be optically inactive. Now let's consider a compounds like this one, and as you can see here, nitrogen has a hydrogen, and if you take the mirror image of it, you are going to get nitrogen, hydrogen, and this one. As you can see, these two are non-superimposable. Now, what can you say about optical activity of it? This compound is optically active. This is because the interconversion is not possible between them. Because nitrogen here is present in a ring. If you observe, nitrogen is in a ring. So, to convert to this form, it should first cleave the bonds, and this bond should turn over, and this would require a lot of energy. As a result, this is not possible. After discussing some properties regarding amines, let us talk about their methods of preparation. First, we will be talking about Gabriel phthalimide synthesis. Now, first see what it is. Here, you take a terephthalic acid. You call it as terephthalic acid. And if you treat it with ammonia, and the conditions for this reaction is, first you have to supply high temperature, and next you have to supply a base and Rx, and then hydrolyze in the presence of acetic medium. You're going to get back your terephthalic acid, and you're going to get a primary amine. As you can see, you're getting a primary amine. So this reaction is favored only for primary amines, and we cannot get secondary or tertiary amines with this method. Also, you can see the net solution is acetic because you are getting an acid here, and also this is an acid. And one more important thing is that all the conditions which are favored for SN2 reaction are favored for this reaction also, because in this reaction SN2 step is involved. We will see what this step is and how it is involved in the problems. And next reaction is Hofmann bromide synthesis. In this reaction, first you take amide, which is RCONH2, and treat it with bromine in the presence of base, say NaOH, like this one. When you do this, you are going to get a primary amine. Here also you are going to get a primary amine. This method is not suitable for secondary or tertiary amines, so you cannot obtain these amines. Now we shall see the mechanism of it in the questions. Also, one more important thing is that the intermediate in this reaction is alkyl isocyanate, which is RN double bond C double bond O, as you can see it from here. Now next important reaction is Schmidt reaction. In this reaction, first you take a carboxylic acid. This reaction you were taught in your carboxylic acid chapter. Now it's just a recapitulation of what you have learned. First you take a carboxylic acid. The R group can be either pH or any methyl or any group. First you treat it with ammonia at high temperatures. You are going to get the intermediate as you have obtained in the previous one, that is this one, which is alkyl isocyanate. If you hydrolysis it in the presence of acetic medium, you are going to get a primary amine. So here also you are going to get a primary amine. Now let us see the hydrolysis reactions. Here we have been talking about what hydrolysis. Hydrolysis of this gives you primary amine. Now let's see the important hydrolysis reactions. In the preparatory methods, two important reactions are there. One is the hydrolysis of alkyl isocyanate, and the next one is the hydrolysis of cyanate, as you can see CN here. Now upon the hydrolysis of these two, you are going to get a primary amine. The only difference between these two reactions is that in the first one you are going to get CO2, whereas in the second one you are going to get an acid. You will see how this is formed in your questions. Also, these were covered in your carboxylic acid chapter. Other important reactions include reductions of compound in which nitrogen is in higher oxidation state as RNO2. As you can see, if RNO2 here is subjected to any reducing agent, you are going to get RNH2, which is primary amine. Now, there are conditions for these reducing agents, that is, what type of reducing agents can be used. Now, the reducing agent can be lithium aluminum hydride, or hydrogen in the presence of nickel palladium platinum, or sodium in ethanol. Now, if you remember, this sodium in ethanol we also used in Bitz reduction, where we converted an alkyne to cis or trans alkene, and this one we have used in the chapter alkanes, alkenes and alkynes for hydrogenation. And this one also we have used a lot of times, where it supplies H minus to the reaction. Now, other reagents can include SN in the presence of HCl or Fe in the presence of HCl. If you compare in between these two, Fe in the presence of HCl is more preferred. This is because Fe in the presence of HCl will give you FeCl2. Now, this can be hydrolyzed to give HCl back. That is, this HCl, you're starting with HCl and you're getting HCl as one of the end products. So, the HCl which is obtained as a product can be utilized in the reactant side. So, the reaction is favored continuously, which is that is the forward reaction is continuously favored. Now, here you have used R. If you change with pH and you have treated with a reducing agent lithium aluminum hydride, you are not going to get this primary amine. Instead, you are going to get an azobenzene. This is what you have to remember and keep in mind. Now, other important reaction include Mendes reaction, where you have treated this cyanide with lithium aluminum hydride and you are going to get a primary amine. The reaction is very simple because this supplies H minus ions. Now, this attacks on this electrophilic side and you are going to get a negative charge of nitrogen, and this takes again hydrogen from water, and the same thing happens again because you will be having a double bond then, and one more H minus attacks and you are going to get NH2. As you can see, you have got the primary amine here. Now, next one which we will be dealing is very important one. This is called reductive ammonolysis. In the reductive ammonolysis, you treat an alkyl halide with ammonia and you are going to get RNH2, which is an amine. Here, substitution has taken place. Now, if you treat it with one more Rx, it loses one more H and you are going to get R2NH. Now, if you treat it with one more RH, you are going to get a tertiary amine. Now, if you treat it with 4th mole of RH, you are going to get a quaternary ammonium salt. That is, you have started with simple ammonia, and from that you have got primary, then you got secondary, and then you got tertiary, and then you got quaternary ammonium salt. So, this is very important reaction and you have to keep it in mind, and we will be solving these type of questions and the problems also. Now let's move on to the next part of it.
this one. Where you have RH2. As you can see, this nitrogen has two nitrogens. Now, you have water. So, hydrogen bonding is possible between this water and amines. This is what the indication for solubility is. As you can see, from two hydrogens bondings are possible. Now, nitrogen also has one point, and it can also be involved in hydrogen bonding with the hydrogens of H2. That is like this one. So, here you have three hydrogen bondings possible. Now, if you take any secondary amine like this one, then you have NH. Here you have only one nitrogen on nitrogen, and so only one hydrogen bonding is possible with this hydrogen. Also, this nitrogen is involved in hydrogen bonding with water, like this one, the previous one. Now, if you take tertiary amine, then you have 3M. As you can see, this has no hydrogen. As a result of it, it is not much stable gas, or it is not soluble in water. Now, one more important thing is that if you compare between amine and alcohol, alcohol is more soluble than amine. That is, amine is less soluble than water, as you have seen it here. Now, one more thing is that if you take amine and alcohol of same molecular weight, the boiling point for alcohol will be greater for amine. This is because hydrogen bonding in case of alcohol is very much greater, because as we all know, oxygen is much more lighter than nitrogen. So, hydrogen bonding is more effective, you can say, more effective in case of oxygen. As a result of it, this alcohol has more boiling point. Now, one more important thing is aniline, which is aromatic amine. Here you have, for the amine, you substitute one hydrogen with NH2. So, you have this one. Now, important properties of this one is the aniline is colorless like that, but when you expose it to air, it will turn into like that. The aniline gives you fishy odor. You can remember if in any question you are getting a fishy odor component as a final product, then it can be aniline. Now, while talking physical properties, the most important one is the density of amines. As you all know, in amines, nitrogen has 1 place. Nitrogen has 1 place, and so as a result of it, this can donate electrons to CH++. So you can say that this is the basic. You can say that this is Lewis base. It is donating 1 electrons. Now, the basicity of a compound depends upon these factors, namely the Kb. That is, the Kb of a compound will be more if the compound is more basic, because Kb gives you the dissociation constant. Now, if a given compound has more dissociation constant, it implies that the molecule or the given compound is more reactive. So you can say that it is more basic. And the most important one is the stability of conjugate acid. That is, if the conjugate acid form is more stable implies it is less reactive. So, if the form of conjugate acid is less reactive,